So, we're back for the third installment of the video series, and we're going to cover three topics. We're going to be covering combined gas law, gas stoichiometry, and ideal gas law. Combined gas law is all of the four gas laws that we've been discussing combined into one. So from this one law, we can derive all the others. If any are not mentioned in the question, or if they're kept as constant, we can eliminate them from the equation. So Boyle's law, temperature and number of moles are constant. We just cancel those ones out, and look at that, we have Boyle's law. P1V1 equals P2V2. Pressure and number of moles. Now we have Charles's law. So from this we get all of them. If it's constant, you can just cross it out. So in this question, we're given 50 degrees Celsius, 1 atmosphere, 30 liters. We're solving for a pressure when temperature and volume change. Our changes are up to 100 degrees Celsius, and our volume drops 20 liters. There's no mention of N, so we would just eliminate N from this equation. Oh, there we go. Kind of like that. Oh, there we go. Gas stoichiometry. Not too difficult to comprehend here because you have the stoichiometric background already. We have our equation. What is the first thing that we need to always check for in the equation? That it is balanced. So now we're balanced. And here's the question. If 50 liters of hydrogen reacts with excess oxygen, what volume of water will be produced? Well, we can do that. 50 liters, convert to moles, use our mole ratio to change from what we have to what we want, and then change from moles back to volume. But if you look at these two conversion factors, 22.4 is going to divide by 22.4, and the gas volumes are going to cancel out because every gas has a volume of 22.4 liters at standard temperature and pressure. So for stoichiometry with gases, we can eliminate that, and only the mole ratio is what gets us from what we start with to what we finish with, as long as we have both chemicals as a gas. That's the essential thing. Both chemicals need to be a gas for us to use just the mole ratio and cancel out the two conversions of moles and liters. Last one. Ideal gas law. All right. The difference of ideal gas law with what we've been discussing so far is that the ideal gas law solves for a parameter, not for a change in conditions. So we're solving for a missing parameter. We're going to be given 3 out of these 4 and solve for the unknown, the 4th. The way that we can derive the ideal gas law is by looking at Boyle's law, Charles's law, and Avogadro's law. It's got all the combinations: volume, number of moles, temperature, pressure. So it has all of them into one equation. And then we rearrange it so that we're all solving for volume. Now, volume is dependent upon pressure. It's dependent upon temperature and number of moles. We can combine this into one, maintaining the constants as well in the equation. So volumes equal to K times, K over P times B times A times T times N. So these all are constants. So we can combine those into one. R. R is the ideal gas law constant, and we can rearrange this to solve and put it into the more popular form of the ideal gas law. PV equals nRT. It rhymes. That's how you know it's memorable. I think that's it. I think I'm just going to stop here. So, met the goal under 6 minutes. Check out the assessment now.